Okay, hi everyone. We're back on page 14 of our Calc 3 notes. Section 12.4, we're talking about the cross product, the second of two kinds of vector multiplication. The cross product results in a vector that is perpendicular to both by the right-hand rule. If you're doing u cross v, then you point your fingers in the direction of u, curl it towards v, and there you have the direction of your vector is indicated by your thumb. So these are several properties. I won't read you the properties of the cross product, but just take a look at them. You can pull out scalars if you're doing the cross product. If you're doing the cross product of an addition of two vectors, you can distribute that on either side. Just make sure that the cross product stays on the appropriate side. Cross product of 0 with any vector is just a 0 vector. That's the 0 vector, by the way. And then if you're doing the cross product of a cross product, then this is a nice little property. We don't use it that much. This is a very important property that we went over from the previous example. Okay, a couple important things that happen geometrically with the cross product is if I take the length of u cross v, it actually is the area of a parallelogram that is formed where two sides of that parallelogram are the vectors v and the vector u. So how does that work? Well, the length of u cross v is the length of the definition of u cross v, which is length of u times length of v times the sine of the angle theta in between them, times the normal vector n, which is perpendicular to both u and v by the right-hand rule. So thinking of the length the same as the absolute value, you pull out the length of u times the length of v, right? Because those are both positive values. And then I have to take the absolute value of the sine of theta. However, notice that the absolute value of sine of theta is just sine of theta, because theta is always the acute angle. In other words, an angle between 0 and 180 degrees between the two vectors. So the sine is always positive from 0 to pi. And then the length of the vector n, but the vector n is a unit vector, so its length is 1. So the length of u cross v is really just the length of u times the length of v times the sine of the angle in between them. And we can see geometrically how this will work. So remember, the area of a parallelogram is the base times the height, just like the area of a rectangle. So the base in this picture I drew is the length of u. So there's the base, length of u. The height is, well, what is it? The height is this guy right here. So using trigonometry, the sine of the angle theta is the height over the hypotenuse, right? Opposite over hypotenuse. Hypotenuse is the length of v. So in other words, the height, this side, is the length of v times the sine of theta. So height is length of v times sine of theta, and then we can quickly see that that's the length of u cross v from what I did previously. So as a example 14, we want to find a vector perpendicular to the plane of the points P, 1, minus 1, 0, Q, 2, 1, minus 1, and R, minus 1, 1, 2. So I plot the points P, R, and Q. And when you connect their dots, I drew this one because I could see that it was going to be underneath the x-axis like that. This represents a plane. Now it extends infinitely in all directions, but when we draw that triangle in between the 3 points, we can visualize that the plane would extend infinitely in all directions there, in the directions that it's going. This vector v is the cross product that we're looking for, because we want to find a vector perpendicular to that plane. Means we want to cross two vectors in that plane, and it would stick directly out of the plane because the cross product is perpendicular to any two vectors that you take their cross product. So I'm going to take the vector PQ and the vector PR and take their cross product. And you can see how that works, right? The vector PQ is 2 minus 1 is 1. 1 minus a minus 1 is 2. Minus 1 minus 0 is minus 1. So it's 1, 2, minus 1. And the vector PR done similarly is minus 2, 2, 2. Use our mnemonic device. Try that. Make sure you look back and see how that works. And then it ends up being the vector 6, 0, 6, or 6i plus 6k. There is no j component. It's in the xz plane. So it's in the plane that's sticking straight out at us. So that's how we have to try to visualize that in 3 dimensions, by looking at this 2-dimensional drawing. So I didn't go through this cross product quite as quickly as I did or quite as slowly as I did when I was showing you the mnemonic device. I hope that makes sense. Any questions, please ask.